All right, hi everybody. In this lesson, we will be discussing scientific notation. So scientific notation is essentially just an easy way for scientists to work with numbers that are both really large. So numbers that are like in the millions and billions and trillions, and numbers that are really small, less than one, right? So numbers that are like 0.000001,357, right? Working with those numbers. It's basically a shorthand for doing that. Right? So scientific notation allows us to write very small or very large numbers in a shortened way, and it allows them to be worked with in a more simplified manner. The way we express scientific notation is a product of two factors. Okay? So the first number in scientific notation is always a number that is between 1 and 10. Okay, so this can be a number like 1.5, 2, 3, 4, 5.5, 6, 7, right? But that first number in scientific notation is always a number between 1 and 10. The second part of a scientific notation number is a power of 10. So the product of this number between 1 and 10, and then times 10 to some power, okay, to some exponent. An example of a number written in scientific notation is shown here. So this is a normal number as we're used to seeing it, 1500. The number 1500 written in scientific notation would be 1.5, that's your number between 1 and 10, times 10 raised up to a power of 3. So in this example, this is a number that we normally wouldn't write in scientific notation, but to show you the example here, that is how it would be written. So let's go over how to take a number, a normal number, and put it into scientific notation, because this prescribed set of steps is what you always want to use. So if you're given a number, you want to move the decimal point in that number to the left or right until you reach a number between 1 and 10. That's your first number. So for example, let's say we have the number 45,000. Okay, we can assume that at the end of the number there's a decimal point, right? 45,000, the decimal's at the end. What we want to do is move that decimal point until we reach a number that's between 1 and 10. So we're going to move this decimal point to the left till we get to a number that's between 1 and 10. In this case, 4.5 is a number between 1 and 10. That's our first number. To get the second part, the times 10 to an exponent, we have to count how many places we moved that decimal point. So we moved it to the left, since this is a large number, 1, 2, 3, 4 times. This would be times 10 raised up to the fourth power. So that 4 comes from the movement of the decimal place 4 places to the left. If this was a really small number, right, like 0.00003, we would be moving the decimal point this way. Okay, so we would be moving the decimal point to the right. So in this case, we move the decimal point. We're going 1, 2, 3, 4, 5 places to the right. Okay, so we have 3 times 10, 1, 2, 3, 4, 5 places to the negative. Okay, and we'll do some more examples of this. So another example, 67,200. So in this example, again, our decimal place, take a look, we assume our decimal is at the end. Okay, this is a large number, so we're moving it to the left. So we're going to go 1, 2, 3, 4 places. We're stopping here because 6.72 is a number between 1 and 10. If we stopped here, we'd be at 67.2, and that's not a number between 1 and 10. Okay, so 6.72 times 10. Once again, we moved 1, 2, 3, 4 places. Another example here. Again, we're going the other way. We're going to the left this time, to the right. So we're going to move that decimal point 1, 2, 3 places till we get between 4 and 8, 4.8. 4.8 times 10 to the negative third, right? Since we moved, since this is a very small number, and we moved to the right. So let's say we're going the other way, 4.78 times 10 to the 8th. Now we want to take this number in scientific notation and write it as a normal number, right? A regular number, a whole number, So what I like to do is I like to start by just writing the initial first number here in the scientific notation, okay? And we know that we moved our decimal point 8 places to get to this, right? So I've already got 2 spaces here, 1, 2, 3, 4, 5, 6, 7, 8, okay? And then I just fill in my zeros, all right? There's our number. So going, either way is not difficult. Just make sure you understand that we're not adding 8 zeros here, but we're adding 8 places after the decimal. All right. So at this point, I'd like you to please pause the video and do these 3 practice, and then we'll do them together. All right, welcome back. So for this first one, we're putting 1,569,000 into scientific notation. So again, we want to assume that our decimal place is at the end. Okay, we want to move the decimal so that it goes to a number between 1 and 10, which is going to be right here. We're going to want to stop. So 1, 2, 3, 4, 5, 6 places to the left. 1.569 times 10 to the 6th. Next one, 0.00305,836. So in this case, again, we're going to move our decimal place until we first reach a number between 1 and 10. In this case, it's going to be right here, right after this 3. We get to a number between 1 and 10. If we went one more, we'd get 30, right? That's not right. So 1, 2, 3 places. Okay. And since we're going here to the right, it's a very small number. We know we're going to have a negative exponent. So we've got 3.05836 times 10 to the negative 3. Last one, 7.2 times 10 to the 4th. Again, we start off by writing our initial number there. And we know we move the decimal point 4 places. So 1, 2, 3, 4. Fill in our zeros, and you have 72,000. 72,000 as a normal number. Okay. All right. So this is the recorded lesson on scientific notation. And if you have any questions, be sure to ask them.